So, ladies and gentlemen, I'd now like to introduce Alan Norbury, who is a Central Technology Officer from Siemens, who are our keynote sponsor. Alan started his career in 1978, so the mathematicians amongst us will work out he's been with the company only 40 years. He was telling me he's only 30 years of age, so quite an achievement there. He's worked in Germany, in the UK. In 1997, he set up a team of application specialists to make best use of Siemens and their industrial technologies. He comes with a high pedigree, a fellow of the Institute of Innovation, Digital for Industry Leadership Group, Northern Robotic Network, to name a few. So please join me in welcoming Alan.
Thank you, cheers. Morning everybody. Can you hear me okay? So yeah, my name's Alan Norbury, I'm Siemens Industrial CTO. Yes, started with Siemens back in 1978 as an apprentice. You're probably thinking what a boring old sod he must be, working for the same company for 40 years. But actually Siemens, as you probably know, is quite a big company, quite a diverse company, and I've worked all over the world. Spent some time in Germany, Singapore, America, most countries in the world actually, working for Siemens. So it's been quite an exciting career. Siemens in the UK, we're probably one of the only companies that both provide technology and also manufacture technology. So in the UK, we have 15,000 employees. At the moment, we have 14 manufacturing facilities, which is where I do all my learning, by the way. And you've probably heard in the news a couple of weeks ago that Siemens have announced that we intend to build a new facility to manufacture trains in Goole in East Yorkshire. It's going to be a £200 million investment, and we'll be employing about 700 people. Also announced 2 days ago, Siemens are also going to invest in an additive manufacturing facility in Worcester. So that'll be a £27 million investment, employing 50 people on top of our existing employees in Worcester. So Siemens, a company called Material Solutions, a couple of years ago, and they are experts in commercialization of additive manufacturing. And the reason we invested in them is because they built the world's first gas turbine that actually has worked correctly at full load test. Now, that wasn't the only reason. The other reason that we were looking at this new technology is because we went from 2 years from original design through to full load testing down to 2 months. So imagine how the impact that has on innovation and how to bring products to the market a lot quicker and address the challenges of your customers. So it's quite an exciting company that I work for. This might be familiar to you. So I make no excuses for explaining what Industry 4 is, because there's always somebody in the room that doesn't quite understand it and know enough about it. I refer to it as Britain's fourth industrial revolution. And the reason I say that is because we started it. So we started it with water and steam driven energy. So Arkwright's spinning frame and Samuel Crompton's spinning mule meant that we were the centre of excellence for the mass production of cloth in the UK. The second industrial revolution was when we saw mass production. So this is where we started to produce lots and lots of the same thing. So the first examples of that, I think Henrik referred to it in America, was when they started to mass produce meat production. So it was used in the slaughterhouses in Cincinnati. And we all remember the Model T Ford. You could have any colour you like as long as it's black. And that was all about the mass production of the same product. Third industrial revolution was when we started to see IT being used in manufacturing. This is where we started to see the first evidence of PLCs, programmable logic controllers. Siemens' very first PLC was called the Somatic G. It was announced in the Paris Machine Tool Fair back in 1959. So we've been working with automation for quite a few decades, even before my time. Fourth industrial revolution has already started. And you'll notice there I've got a bracket around the R. And the reason that I've done that is because most manufacturers already have buildings. And the challenge that they have, they're going from a factory that might be Industry 3 or even Industry 2 possibly, to become an Industry 4 digital factory. So in most cases it'll be an evolution. The challenge there is, where do you start? If you've got an existing factory manufacturing products, where do you make those initial investments? How do you de-risk those investments? What sort of people should be you talking to? Who's going to support you in that process? And I'll explain some of those, answer those questions in a minute. So, the fourth industrial revolution, Fourth industrial revolution is about the technologies on the right-hand side there. So virtual reality, so this is all about developing a virtual model of something, whether it's a machine, whether it's a factory, whether it's a layout of a factory, about virtual training of people. So we invested £250,000 in a virtual reality cave in our factory in Congleton, where we manufacture variable speed drives for the world market. And that investment, you think, £250,000, that seems a hell of a lot of money. And the reason we did that is because we have a factory that's manufacturing products, and we can't afford to stop production while we're innovating. So we do all our innovation in the virtual world today, and I'll explain that in a little bit more detail. Augmented reality, people think of augmented reality being putting the big goggles on your face, but imagine you're an operator, you don't want to spend all day with goggles on your face. So are there new forms of augmented reality? And the answer is yes. So for example, you can actually laser inscribe onto a surface your work instructions, so it doesn't necessarily have to be in the format of goggles. Digital twin, so this is all about having a virtual model and a physical model, so you can do all your innovation in the virtual world. Cyber physical systems is about closing the loop on that digital twin. So as you're manufacturing products, feeding data from the manufacturing process back into the virtual world, so you can optimize the manufacturing environment. Big data doesn't mean anything unless you can harness that data, unless you can filter that data and convert it in what I call business data. And this is why we need smart algorithms to be able to convert that data into something useful. Internet of Things, which is why we're here today, all about smart sensors, smaller and smaller devices, having more and more capability, connecting to the outside world. Advanced robotics, and I don't just mean big robots in cages, which is what most people think of robots as being, also cobotics, so robots working alongside humans, supporting humans. So in our factory, we've just invested in 3 cobots, and we're trying to find ways of working with our operators to optimize some of their process, some of the boring, repetitive tasks, and make life a bit more interesting for them, so the cobots are supporting them. And that's also to do with the culture as well, which I'll come on to in a minute. Cloud technology is all about accessibility of data on a global scale, so you can compare machines globally, you can compare factories globally, and the way you're manufacturing your products. 3D printing, and I just referred to additive manufacturing that we're investing in at the moment. So one of the benefits of additive manufacturing is that you can make some very, very different piece parts that you could never achieve in any other way. So in the past, some of these components might have 20, 30 piece parts, whereas now you can do it in a single piece part. And the other benefit of additive manufacturing is you can put curvatures within the product, so it can give you different heat transfer properties. Obviously we need to do all this in a secure way, and that's where cybersecurity comes into it. So digitalisation is changing all our lives. It changes the way we stay informed, it changes the way we travel, it changes the way we buy things, and it also changes the way we manufacture products. And it's also putting increasing pressures on manufacturers. How do we address this challenge of digitalisation? How do we embrace digitalisation and bring some sort of benefit to our manufacturing processes? So if you look at some of the business models that I'm sure you're all familiar with, so again, in the past, if you wanted to read something, you go to a library, you pick up a book, whereas today you can have a Kindle, your iPad, and you can actually download books. In the past, if you wanted to listen to music, well, when I was younger, we go to a record store and you buy a vinyl record, whereas today you can stream music onto various different devices. Apparently vinyl records are popular again, so people buy them, but they don't play them. Not quite sure how that works, but it's changing the way that we actually listen to music. And again, if you wanted to get a phone number for a company in the past, you go to Yellow Pages, whereas now you can get it on your app, and you can get feedback from other people as well that have used that service. And also the way we travel, so if I'm in London, I tend to use Uber a lot, and it's very, very convenient. You don't need cash, you can download your receipts when you get home. So the point that I'm trying to make there is, that these businesses that are becoming masters of data are becoming very, very successful businesses. So why do we need all of these? What are the drivers behind the fourth industrial revolution? Well, the drivers are you and I, it's consumers. So there's a demand from consumers for products to come out before they're actually available. So the good example of that, I always use the mobile phone, so I got myself what I thought was a brand new phone, a Samsung S7, and within a week they brought out a Samsung S8, and now they're just bringing out a Samsung S9. So if you think about it from a manufacturer's point of view, consumers demanding the latest technology before it's available is a massive challenge. So how do you go from announcing a new technology to mass producing it? It's an incredible challenge for manufacturers. The other challenge that we have is consumers want personalised products. There's a great example of that. If you were to buy a brand new car, you'd expect to specify the colour, the engine, the trim, absolutely everything in the car. And the amazing thing is, your customised car is manufactured on the same production line as everybody else's customised car. So you think, all right, that's a high value product, I kind of get that, I understand that. But if you look at some of the other sectors, like food and beverage, there's a company in Germany now called My Muesli, and you can go online and you can actually configure your muesli to your individual taste. So you can take certain things out like nuts or raisins or whatever and add certain things in you like. And My Muesli will actually manufacture that muesli to your individual taste and deliver it to your door. Now you think about it, if that suits your individual taste, you'll pay more money for it. And that covers all sectors, not just food and bev, not just automotive. The one that really excites me is pharmaceuticals. So if you've got an illness, no matter what weight, size or gender you are, you go to a doctor and they'll give you the same medication as they would somebody else. And you react in a different way. So what they're working on today is personal medication. So what you'll see in the next 20, 30 years, you'll be able to go to your doctor and they'll have information about how you react to certain things, your weight, your size, your gender, your DNA, and they'll be able to prescribe a medication to suit you as an individual, or even a combination of medications. It'll change the way we actually go to market across all sectors. No matter which sector you're talking about, there'll be an element of customization. Now, the other challenge that we have is productivity in the UK. So everybody perceives productivity to be about making more products with less people. So everybody's frightened of automation and robotics taking over our lives and taking over our jobs. However, if you was to add value to your products through customization such that your customers pay more money for it, you can actually increase productivity with the same number of people, which is exactly what we're doing in our factory in Congleton. So our vision is to keep the same number of people, but to increase productivity by adding value to the products, by customizing products, because more of our customers are now wanting certain versions of that product that we'd never be able to manufacture in the past. So we need to start to embrace things like virtual reality, robotics, fully connected environments, including our supply chain. The other thing that we need to consider is efficiency, and I don't just mean energy efficiency, that's very important obviously, but also resource efficiency. So are our machines capable of making more than one product? Are they flexible and adaptable enough to be able to work around the product, such that the product defines its destination? So these are the drivers behind the fourth industrial revolution, it's you and I. And as I said before, it covers all sectors, whether it's discrete, whether it's process. No matter which sector you're talking about, there's an element of Industry 4, element of customization. So this is sort of Siemens' vision of our factories, where we would like to be. And you'll probably see there that all the way through from design through to services, there's an element of data, a thread of data going through all the life cycle of manufacturing. And the utopia for most companies, what you'll find, most manufacturers, they have lots of different data sets coming from different types of machines in lots of different formats. And the utopia is to have a consistent data set throughout the whole life cycle of manufacturing. Now, going back to our challenge in Congleton, where we manufacture variable speed drives, we make drives up to 250 kilowatts. We also manufacture drives in Germany, in Karlsruhe. We also manufacture drives in China. From a consumer's point of view, they want the same look and feel with every drive. And the way we solve that problem is by having one existence of the truth on a global scale. So we use something called team centers, the Siemens software, so we can have that one existence of the truth. That doesn't change, but within your manufacturing environment, you can add on top of that. So you get consistent look and feel. The other challenge is throughout the life cycle of manufacturing, you're generating data. And the challenge there is how do you capture that data? How do you make use of that data, convert it into value? So we use something called MindSphere. If you want to know a bit more about MindSphere, we'll be able to talk about it on our stand just over there. And I'll explain what it means in a second on the slide. Now, the other thing that we do is, rather than try things in the manufacturing environment, which is always a risk, of course, we have a digital twin all the way through the life cycle of manufacturing. That means you can try things where they're impacting on the manufacturing process. You can try things you've never done before. So the idea is to try something new and fail fast. If you fail fast, learn from that, try something else. But don't do it actually in the manufacturing environment, do it in a digital twin environment. So cyber-physical systems sounds very complicated, but it's not actually that complicated. So in an ideal world, what you would do, if you're going to manufacture something, you do everything in the virtual world. So the example I use is a bottling line. In a bottling line, you'll have a filling machine, a capping machine, a labeling machine. If you broke that production line down into individual production units, what you would do is you virtualize that whole production unit. So everything you see on the right-hand side, most of this you can do today, some of it you can't. You would virtualize everything on this side. So the PLC code, for example, you could virtualize. The actual mechanics you can virtualize, the automation, the safety. And then you go through all the prototype iterations in the virtual world, so you get to a point where you're happy with that and you know it's going to work. You migrate the data across to the physical world, so that could be migrating PLC code, it might be manufacturing some of the mechanical parts with additive manufacturing, and then you start making products. And as you go through the life cycle of manufacturing your products, your digital footprint will actually get bigger and bigger and bigger. The bigger that becomes, the more you can do with it. So the machine could actually self-optimize. It could self-adapt. It could potentially self-heal. And you're probably thinking, how the hell can a machine self-heal? Well, the technology behind self-healing already exists. So things like condition monitoring. So by analyzing the vibration or temperature or humidity or pressure of a manufacturing process, you can tell when something's going to fail before it actually fails. And then you can do something about it. So today, that'll be a manual intervention, but in the future, it'll be fully autonomous. So what I mean by that, let's say on a conveyor system, great example, Heathrow Airport, they've got 4,000 conveyors there. Each conveyor will have 2 motors on it, 1 or 2 motors. They'll have 1 or 2 bearings within the motor. Just takes one of those bearings to fail and they'll havoc all around the M25. However, by using condition monitoring, you can actually tell when that motor's going to fail, or the bearing's going to fail before it fails. Then you can make a decision. Do you want to stop the machine and repair it there and then? Do you want to slow it down so it lasts a little bit longer so you can repair it in the normal maintenance period? Or do you want to divert production to another conveyor? So at the moment, that's a human intervention, but that will be fully autonomous in the future. So let's say we're making product A, and we're thinking, hang on, we want to add value to our product. I want to bring an element of customization. Can my machine make more than one product? So we feed the data back into the virtual world, the manufacturing data, and we try making product B in the virtual world. And if we could achieve that and go through the prototype iterations, we migrate the data across and we're making product B. And that's what we mean by cyber-physical systems. The other challenge that we have is what you find with both big manufacturers like Siemens is that what's the point of doing all this great innovation in your factory when high percentages of your manufacturing is in the supply chain? And it tends to be 80 or 90% for most big manufacturers. So what I've decided to do with this particular slide is to turn it on its head and say, well, this challenge around mass customization, one of the biggest problems is stock control. If every product is different, imagine the amount of stock you need to hold, imagine all the work in progress. How do you reduce the cost of your stock? And one of the ways of doing that in the future will be to migrate your mass customization vision down to your supply chain, such that every product could be different. So one of the visionaries behind Industry 4.0, a gentleman called Dr. Siegfried Deyers from Bosch, he said in the future, the raw material will hold all the information within it for its manufacturing process, its logistics, and what part it plays in the final product. Could be a car, for example. So using things like RFID technology, a lot of people today use barcode, data matrix code. RFID means you can write to it as well as read from it, you don't need line of sight. So if that RFID tag held all the information within the raw material, effectively that product could tell the machine what to do to it, rather than the way we manufacture today, which is the other way around. So that means every product could be different, so we've got mass customization. And if we have true connectivity into our OEM, we could optimize that manufacturing process to actually fit with our machine in the OEM. Therefore, we'd reduce the amount of stock that we're holding. And if there's a challenge with logistics, say there's a problem on the M4 or M25 and that part doesn't arrive in time, if we have flexible manufacturing, that machine can do something else while it's waiting for that part to arrive. So the raw material can define its own manufacturing process, its logistics, and also what part it plays in the final product. It's quite visionary, and we're a long way off, by the way. This is quite futuristic, but it's something to aim towards. So as I said before, there's a challenge around big data, and they say by 2020 the volumes of data will be around 44 zettabytes. I think the last figure was I heard. A zettabyte is 10 to the power 21. And to put that into perspective, if you was to digitalize every word that's ever been said since time began in every language, that equates to about 42 zettabytes. It's a lot of data. So how do we harness that data? How do we make use of that data? How do we filter all the data out, all the noise that we don't really need to use? And that'll cover all sectors, by the way. So at the other end of the spectrum, we need visualization, some information that actually tells us when something's going to go wrong before it fails, or it tells us information about productivity, it tells us information about energy consumption. And this is where we'll find that more and more organizations will be developing apps, not just Siemens. There'll be lots of SMEs, there'll be universities, all types of companies developing what I call cloud-based industrial apps. And the glue to all of this is something called MindSphere. So MindSphere is an open access, cloud-based IoT operating system. And this is a whole ecosystem. This isn't just about Siemens. This is about more and more devices, sensors that can go onto MindSphere, organization developing apps to give you that visualization of that useful information, and then the cloud. So we started off working with SAP HANA, and now we're offering Amazon AWS. The reason we did that, we wanted to have a platform that was real-time, that could respond within 40 milliseconds. And we actually wanted something that was very, very reliable as well. So this is our current offering in terms of an IoT platform, and it's an ecosystem. So anybody in this room can be involved in MindSphere. And the great thing is, if you develop an app, the visibility of that app is available anywhere in the world. So it's a great way of growing a business from something very small to very, very big. From Siemens' point of view, we will be the custodians of the data. So we're going from selling bits of equipment to selling bits and bytes. So we'll end up selling data. So it's quite a challenge for us, a big organization, to change our business model to something very, very radically different. So in summary, there's three things to take away from this. A lot of companies say to me, Alan, where do I start? And I think most cases it'll be about the communications infrastructure. And I say to the companies, well, walk down your factory, look at all your machines and ask yourself the question, how many of my machines are capable of becoming part of the Internet of Things? In other words, does it have an Ethernet port on the machine or a wireless access port? And that's a great way to start. And the way to do that is ensure that you specify communications, that you know all the machines are capable of talking to each other, so you can eliminate bottlenecks, so that your shop floor can communicate to your office environment, so you can manufacture to order, and then extend that communication into the supply chain, so you can reduce the amount of stock that you need to hold. And it's a step-by-step approach. Virtualization will be the next step, and this is all about accelerating innovation cycles. So our factory in Congleton, when we're developing a new piece part for our drives, 3 years ago, we'd made 9 physical prototypes. Now we're down to 3 physical prototypes, because the rest are done in the virtual world. And then we 3D print the part, so we can actually bring products to the market a lot quicker than we've ever done before. We also use it for training our staff. So before a machine arrives, we ask for all the 3D CAD drawings, and we train our operators before the machine arrives. We also use it for ergonomics. So we can actually put a human in a cell, a virtual cell, and we can see how far they're stretching and what impact it has on their bones. So we have 2 pieces of software, one's called Jack and one's called Jill for the male and female skeleton. That does two things. First of all, obviously it optimises that physical environment and our efficiency of that cell, the manufacturing cell, but it also changes the culture of our staff. And that is very, very important. If your operators don't come along with you in this journey, it'll never work. So you've got to actually change the attitude of our staff and our people that are working in this environment, such that they embrace it and support it. And last but not least is skills. So we need a combination of hybrid skills. We need the virtual reality skills, a bit like the gaming skills, to work in that virtual environment. We also need engineering skills, traditional engineering skills, and we also need IT skills in the same individual. Why do we need this? Well, ultimately mass customization, working towards that vision of mass customization where every part is different, batch sizes of one, shorter time to market, and our vision there is to get to zero physical prototyping. So our first physical prototype is our final production unit. And last but not least is flexible manufacturing, so that we have the capability of making more than one product.
Technology is transforming the world of manufacturing. The days of smokestacks and oily rags may have long gone, but some of the old manufacturing problems remain.
It's really hard to predict what the world's going to be like even in 6 months. Trying to forecast orders from customers is more than a black art.
We do have downtime in our factory as a result of not having the right parts in place at the right time, so we could become a lot more productive if we had connection with the information.
The answer to this is to create factories which are as flexible as they possibly can be.
To do this, Siemens are collaborating with Sheffield University's Advanced Manufacturing Research Centre.
Industry 4.0 and the Internet of Things and cloud manufacturing, there's a whole variety of names. It is about a more automated, more integrated factory, and that's what's happening. It's bringing it together now. This idea that you can put everything in the cloud and have access to it is a fantastic idea.
For Siemens, the challenge is to use cyber-physical systems to improve their manufacturing operations.
Cyber-physical systems are the sharing of data between machines or embedded systems. If you think about a car and it's got many systems in it, anti-lock braking, climate control, if you think of that as an embedded system, if those cars could communicate and share information, for example, about their speed, and that information was in a cloud, you start to be able to add value by looking at the control of those cars. We have 5 factories, 2 in Germany, 2 in China, and here in Congleton. And to start to manufacture products on a truly global basis by receiving orders and then deciding which factory makes which product, we have to start to elevate all that factory information up into the cloud. Siemens' product is called the MindSphere.
Eventually all of our equipment will be hooked up, so all the information and data that we're not using from our equipment will go into MindSphere. As we get more of the systems set up, we'll be able to actually have the machines making self-adjustments, finding out what a problem is, adjusting further upstream and fixing it so that we don't have an operator having to make adjustments themselves.
We're trying to make more customised products, and I think cyber-physical systems will give us that flexibility to be able to make 1 of those, 5 of those, 10 of those, the same cost position as we historically might have made 2,000 of the same product.
Linking up every element of a factory into a cyber-physical system is easier said than done.
Getting the data in the first place has been a big challenge because a lot of the sensors and actuators in a modern factory are not easily connectable to the cloud. So a lot of companies like Siemens are working on that connectivity to get the data from the factory floor all the way through to the cloud.
Siemens aren't just making their factories smarter, they're increasing efficiency by creating virtual factories.
We're seeing it very rapid expansion in virtual and augmented reality now, and it is almost becoming the core technology that we're linking into everything.
The virtual 3D factory is based on a premise that when you start making things in the real world with bricks and mortar and buying machines, if you get it wrong, it can be hugely costly.
In the digital world, you can make mistakes, and it's a lot cheaper than doing it in the real world. It also enables a lot more collaboration with the different departments.
We have an infrastructure, the VR cave, and that allows individuals in the factory to immerse themselves in the models, and what you find is that virtualisation gives us much fewer mistakes when we then put that into practice.
This new cloud-based technology is a far cry from how factories operated only a few years ago.
In my career, we started with a slide rule. We hadn't got a calculator and we didn't have a computer available to us. And we're now at this point of augmented reality, cyber-physical systems. It's very hard to look into the future, but it's much more automation. I think that's how, in the Western world, we're going to balance our economy.
I think Industry 4 is going to be a journey, and it will be around for the next 10 to 15 years.
If we're connected all the way through to our suppliers and we actually have quick exchange of data that they're able to see what we can see, then the benefits are massive.
It seems clear that factories of the future will become increasingly reliant on the power of the cloud.
So just 3 things to take away. I think we need to embrace digitalisation, and that's all about the people and the culture and the fact that we want to utilise innovation in a better way. It's all about investing in digitalisation, taking risks but in the right way. So working with catapult centres, for example, to de-risk some of those investments. And last but not least, it's all about we need to be leading the 4th industrial revolution exactly as we did the first. Thank you.